Good afternoon. I am in charge of development of a smart ship in Samsung Heavy Industries. Today I'm going to talk about development of ship automation system and unmanned shipping. We are shifting from smart ships to unmanned ships. So it's time to think about what autonomous systems we're going to mount on unmanned vessels. And as you know, Samsung Heavy Industry is a shipbuilder, so I'm going to talk about this topic from a shipbuilder's first perspective. First, I'm going to show you the global status, and I will introduce you our standard solution. This is a solution for S vessel. And we are using digital platforms to digitalize vessels, and we will also commercialize the digital S vessel. And many ship owners are thinking hard about how to reduce crews on board. And these two systems are already commercially available. And then we also have been working on the rest of the systems you are seeing on the slide. You heard a lot about autonomous ships in the previous session. When we talk about autonomous ships, we have to distinguish autonomous ships and autonomous navigation. And my company is validating autonomous navigation. So I will show you the global status of autonomous ship development briefly. And this is an engine maker. Engine will get smarter by combining engine data and chip data. And engine diagnostics will be done inland. That means there should be cooperation between shipbuilders and engine makers. I think you heard about this on the previous session. I'm not trying to tell you technical point of views here. This project had this order, and this is being developed by a shipyard in Kongsberg. And traditionally, ship owners asked a shipyard to design and construct a vessel, but this is a case where you can see Kongsberg also won the order to be part of the design process and construction process. And this is another example from Wasilla in Japan. The Japanese navigation makers are developing remote systems. And this is another case. For now, this is a vision-based solution. This is already commercially available. For this device is drawing attention in autonomous navigation. It is already commercialized. This is a very famous manufacturer in the States. So what is the Samsung Heavy Industry going to do as a ship builder? I love this term, way to reach fully autonomous ships. So what is the Samsung Heavy Industry going to do? We had 4 phases. They may coincide with or match with IMO's autonomy levels. An S vessel we are trying to commercialize is located on the left-hand side. And Samsung Heavy Industry is planning a half-crew ship. Yes, we are moving forward fully autonomous ship. That's the main trend. But until we achieve fully autonomous ships, we will introduce a half-crew ship so that we can reduce the workload of crew on board. When we started this plan, we came up with this roadmap, and whenever we met with ship owners, they said there should be at least 14 crew on board. And that's the minimum number of crews required. Anyway, we are developing a lot of technologies to reduce the required number of crews by half. This requires integration of systems. Then, where are we standing now? What are the standard solutions for S vessel? I think you must be familiar with this. The smart ship technologies we're pursuing is that the ship should be intelligent, and that requires enhanced operation and enhanced efficiency. To make that happen, we will introduce onboard solutions and onshore system. And to do that, we have to reduce costs, and we have to make sure cybersecurity measures are in place. So this is our aim and goals. This is the platform that we are going to use for our S vessels. The main purpose and function is monitoring, and every single thing on the table is a solution. You can combine different sets of solutions. If not necessary, you can take some of them from the combination. Depending on different ship owners, different solutions, different sets of solutions will be used. These are basic tools: route optimization and trip optimization. This will integrate a design of ships. We can create these based on AI. Since we are a shipbuilder, we are using shipbuilding data to provide these solutions. And route monitoring and ship performance analysis and actual motion can be also monitored. In HASMS, this is a very traditional solution. We are developing this because when we work on smart autonomy, condition-based monitoring was one of the priorities. But at the end of the day, monitoring systems for hulls were not available. So in order to develop the healthy monitoring system for hulls, we are introducing HSMS, and this is a CIS monitoring system. And many developers and companies are doing this. We call this S-Vision. This is a surround view system. It offers a round view as well as front view. This is already commercially available. This was developed 5 years ago, and it has been functioning well. Some owners took this as an option, and there are other ship owners, they had good words about this system, and they want this on their vessels. It is well received in the market. And this is a risk monitoring system based on AI. When we talk about HSMS, this will provide additional extra functions. This is MRV and DCS and daily report. And data will be inland and tracked. We will offer warranty management, collaborative maintenance as well. So everything offshore and onshore will be connected. That will bring benefits to ship owners. That's our proposal. So I've introduced you monitoring systems, and then what is the next step? Samsung Heavy Industries has invested more than 70 vessels. All the 70 vessels have this system. In 2013, we did validation on this system, and for a round view, the system is on 50 vessels. At the bottom of the page, you can see the documentation from ABS and other registers. We also have an approval and certification of cyber security from different classification societies. Cybersecurity is one of the top priorities, so we have approval and certification from 4 different classification societies, whether it is autonomous navigation or autonomous operation, we thought cybersecurity is one of the most paramount concerns. And then what's the next step? We are working on reducing workload of crew. So for that, we developed condition-based maintenance. This is about how well you're going to be at maintenance of your equipment. And then we are currently talking about e-logbook. There are many digital documentations developed by other manufacturers. What we are talking about is automatic data logbooks, not autonomous logbooks. We are going to collect all the data from ships, and that will be done automatically. That will reduce workload of a crew. And this is not on the slide, but we are also working on remote validation system. Once the number of crew is reduced, cost will go down. And this will require robots to do work that used to be done by humans. So we spent quite a long time on developing this system. So this is finally commercialized this year. It includes electric current measuring function, and this offers maintenance for main equipment. This is not going to be used for main engines. There are other manufacturers that offer similar services for main engines. And for the rest of the equipment, we are providing our CBM. This is electric logbook. So we will receive data from S-Vessel, and they will be automatically examined. And some gauge data is not digitalized, so we may have to go to the bridge and take a picture of the data. To do that, we developed an automatic system. This will be mounted on vessels as early as by the end of this year. But I can say for sure they will be on ships by next year. So we are all doing this to reduce workload of crew, and in the long term, we are going to reduce the number of crew members. And for that, CVM is very important. Next, autonomous navigation ships. I have 5 minutes left, so for 5 minutes, I'm going to talk about autonomous navigation ships. When we talk about autonomous navigation ships, we have to talk about IMO's autonomy levels. When we develop autonomous ships, there are two parts, navigation and equipment. Personally, I think we will have autonomous navigation before autonomous equipment. So personally, I think navigation system will achieve a higher autonomy level compared to other equipment. We are integrating this to existing equipment. As somebody mentioned earlier, ACTIS will be integrated. Our system will be integrated in ACTIS, and we will make autopilot and BMS available. And these have not been commercialized yet. We are testing them, and these can be controlled by operation centers inland. This is a more advanced feature of around view. We call this S-Vision. In early days, we had only one view, but due to cost, this cannot be mounted on test vessels. We are testing thermal cameras, panoramic cameras as well. It has IR light. It is not necessary. IR illuminators. They are not necessary. There is one on the front and there are two at each side. So we are testing IR illuminators at 3 points. And we are also doing object detection. We are testing object detection. We tested this on ocean-going operation, and now we are testing this with bridges, and we already set the height of bridges that we are going to test this system for. And this is MFD. When I watch a movie, I like to use Jarvis, and I hope it can become a kind of a brain that can control everything else. And detection is done by around view. This you are seeing on the screen came from Samsung, but it doesn't have an approval yet. If necessary, we will cooperate with other companies so it can watch everything and take in everything before giving any command. This is Samsung autonomous ship. I think this process is well known. We have static information, user input, navigation sensors. They all come into this system and it gives commands to VMS and autopilot. We tested this process, but it's challenging. The BMS and autopilot, Samsung hasn't developed any BMS and autopilot. That is why we are working with manufacturers in Japan and other countries. This is an user cases. This ship is Hanaraho. We tested collision avoidance as well. We tested this with one vessel, and we also tested this with 2 autonomous vessels. We mounted this on Samsung T-8. And this ship is 133 meters long. This is our own ship, and we tested these ships at sea. This is Samsung autonomous navigation ship's history. We spent a long time on this. In 2019, we tested this model vessel in a tank. You might say this was reckless, but we took the vessel to the sea, and in 2020, we used a tugboat to test collision avoidance. In 2021, we used a larger vessel to test collision avoidance. And by the end of this year, we will do 4 more tests. To do the tests, a lot of efforts and time are required, and much simulation is required. And there are many requests from maritime authorities. So that is why we spend so much time and effort on testing this system. We have to make sure risk assessment is well done. So at the end of this year, we are going to do the second test. So by the end of 2022, obsolete navigation system will be commercially available, and validation will be done next year. So by the end of 2025, this will be used as a main navigation system if it is commercially available. But at least by the end of this year, we will get tests done on this obsolete navigation system. So this is the summary of our service. So if you look at the development status of Samsung heavy industry, you will see that this cannot be done by Samsung heavy industries alone. If you look at the second row of the page, you can see our partners. They play very important roles for us. MS, HMS, we are doing joint researches and tests with these partners.
커머셜로 저희가 인터폴레이션을 해가지고 그래서 제가 말하고 싶은 건
So my point is, smart ships and autonomous operation cannot be done by a single company or single manufacturer. All of us have to work together to achieve that. That's all I have. Thank you for listening.